Hi everyone, welcome to Mr. Naik Math. By the end of this video, you will learn how to construct a direct proof. Now, proof always involves some sort of implication. For example, a of x implies b of x over some domain x belongs to S. Now, this symbol over here means implies that. So, the main strategy for direct proof is to assume that A is true and then show that B also must be true. Now this might seem a bit abstract, so let's take a look at some example. Now the example says, prove that if n is an odd integer, then 3n plus 5 is an even integer. Let's first establish what is A over here and what is B. So n is odd, here n is an odd integer, is A. So this is your A. And 3n plus 5 is even, you probably guessed that, is B. So what is being implied over here? This if-then structure is a good hint. Whenever you see if something, then something, it means there's some sort of implication. So over here, the implication is that A implies B. Now, if you remember, there was some sort of domain involved as well. And the domain over here, that is this x belongs to S, the domain over here is all integers. So this statement, if n is an odd integer, then 3n plus 5 is an even integer. The domain is n is an integer. Now before we start to write proofs, it is good practice to get a feel for the statement and to come up with a proof strategy. So what is our strategy here? Let's write down proof strategy. Now let's suppose that n is some kind of odd integer. Say n is 5. So if n is 5, n equals 5. What does that say about 3n plus 5? 3n plus 5 is going to be when you plug in 5 into n, you get 3 times 5, which is 15, plus 5, and that is 20. Notice that when we plugged in an odd integer for n, you got an even integer as 3n plus 5. Okay, let's try some other odd integer for n. Let's say n equals negative 3. So when n is negative 3, what is 3n plus 5? 3n plus 5 will become 3 times negative 3 plus 5, which is negative 9 plus 5, and that is negative 4. Notice that this is also an even integer. So you can notice that whenever we choose an odd integer for n, we get an even integer for 3n plus 5. But we have only proved this result for these two odd integers. We have only proved this for n equals 5 and n equals negative 3. We wish to prove this for every odd integer. So let's try to characterize what even and odd integers look like in general. So let's see what is even and odd. Even, odd. Now even integers, as you know, look like 2, 4, 6, negative 8, and so on. You get it. But we want to generalize the idea of an even integer. And so we can say that every even integer, if you notice, is a multiple of 2. So we can write every single even integer as 2 times some other integer, which is k. So the way we can express this mathematically is 2k, where k is an integer. Let's do the same thing for odd integers. So odd integers are 1, 3, 5, and so on. Notice that every odd integer is an even integer plus 1 or minus 1, but let's just go with plus 1. So even integers are 2k, and so odd integers will be 2k plus 1. For example, 3 can be written as 2 times 1 plus 1. 5 can be written as 2 times 2 plus 1. And of course, k has to be another integer. So now we're all set up. We know how to represent our even integers, we know how to represent odd integers. Now somehow we need to incorporate this into our proof strategy. So what would happen if n is any odd integer? So n would be 2k plus 1. If n is 2k plus 1, what does that say about 3n plus 5? So 3n plus 5 would equal 3 times 2k plus 1. 3 times 2k plus 1 plus 5. And somehow we need to prove that this is an even integer. So this is going to be our proof strategy. Finally, we are ready to write our proof. So let's write down proof. Remember, we assume that A is true and then prove that B is also true. So we assume that n is an odd integer. Assume n is an odd integer. Then n would equal 2k plus 1, because every odd integer can be written as 2 times some integer plus 1. So where k is an integer. So therefore, what are we trying to prove? We're trying to prove that 3n plus 5 is an even integer. So let's go therefore 3n plus 5 would equal 3 times n, which is 2k plus 1, plus 5. Expanding this, we have 3 times 2k plus 1, which is 6k plus 3 plus 5. Simplifying, we have 6k plus 8. Now somehow we need to write 6k plus 8 as 2 times some integer. So let's factor out a 2 from 6k plus 8 and we get 2 times 3k plus 4. Now remember that k was an integer, because we said that k is an integer. So if k is an integer, 3 times some integer plus 4 would also be an integer. And so we can say since 3k plus 4 is an integer, 3n plus 5 is an even integer. And this completes our proof. So let's summarize this procedure. For any direct proof, we assume that A is true and then show that B also must be true. So in our example, we first identified what is A and what is B and what is being implied. Next, we came up with a proof strategy. Notice that only when we had a solid game plan did we actually begin to write the proof. This is something that you should try to follow while you are writing proofs as well. Never start to write a proof without knowing what you're going to write. And that, ladies and gentlemen, is how you write a direct proof. Thank you for watching and see you in the next video.